Welcome everybody to today's webinar about emission calculation. It's the second time I'm doing these slides. The first one was 4 weeks ago when we had some German partners in the session. Today we have some international partners from somewhere in Europe. And let me introduce myself. My name is Bernd Welter. Keep it short. I'm working for PTV for about 20 years now. My core business is the knowledge transfer towards partners, integrators, and I'm cooperating with my colleagues somewhere around the globe, mainly in the CEE region. So this is why my Polish colleagues Wojciech and Tomasz are here in the session as well. I'm also in close contact to our Italian office, like Daniele and Fabio, who are in the session, and some other offices around the globe. And it's a great pleasure for me to be part of that international team. So, well, let's look at emission calculation. By the way, any one of you, as long as you do not have to be part of the session, just mute your microphones. If you want to ask questions, that's the part of that session. Unmute yourself, just ask the questions. We are not hundreds of members today, so you can easily be part on audio level for this. What is today's topic? In the recent months, I was asked for what is emission calculation by different parties, external parties, even internal parties. And it looks like that we need to create some kind of an initial vocabulary. So it reminds me of school times when we had to learn about different terms and their meanings. And my goal for today is to introduce you into the world of emission calculation, as far as I know it from our transport logistics scope. So I want to mention many of the buzzwords in that topic, and I want to make sure that each one of you has a global and generic understanding of the mechanisms of emission calculation. So it could be interesting for you who is using emission calculation. How is it? How does it work? What parameters are required? What output can you gather from that mechanism? It will not be a technical session today. It's more a, let's say, functional scope, and we can also discuss about this at the end of the session. I also would like to introduce you to my colleague Stephan Ruppert, who is the product manager in charge of emission calculation and developer, PTV developer. Stephan, do you want to say something about you?
Yes, short words. So 20 years with PTV, Stephan Ruppert is my name, and I'm product manager for the developer components and PTVX server, of course. And yes, I'm working with the emission calculation now for more than 12 years. Was member in the DIN and CEN working group for the setup of the standard, the EN16258, and so working with this now for more than 10 years. Hopefully, I can add some information.
I'm quite sure you can. You did contribute with a lot of details last time when we had the German session. Okay, so that means it's not only a presentation today. You can also ask your questions during the session. I have prepared some slides. I have a demo client. We will look into some web pages that are also public. I have already mentioned them in the session chat. So let's be interactive together and discuss the topic from your perspective and our perspective as well. There are some topics I do not want to talk about today, and that's, for example, how you could calculate partial emissions on order level. That's well, if you talk to 10 parties, you will get 12 opinions probably how to do this properly. Stephan, maybe you can give us some info about that subtopic later, though it is not part of the session today. And as I said, it will not be a technical training. Okay, so what is emission calculation about? Quite simple. Nowadays, everybody is talking about climate change and emission, pollution, and these kind of topics. So there are different parts where you would like to reduce your emission, where you have potential to reduce your emission. For one of those parts is the motivation, is the avoidance and the optimization. Let's say you have a set of resources you can use in your transport logistics processes, and you want to make sure that you use each of those resources in the optimal way. That's why you usually do some kind of tour optimization. You are trying to reduce kilometers, distances, driving times, and you also optimize your global network of transports. You can also change the means of transport. So by deciding which kind of means of transport you want to use on a road, by train, by boat, for example, that could also be helpful in minimizing your emission output. You could discuss about using alternative engine types like regular old school fuel versus CNG and LNG, hydrogen, fuel cell, and so on. Whole e-mobility topic as well, of course. And you could also discuss about compensation, that you buy CO2 certificates to, well, some kind of have a proper reporting of the emission that you are responsible for, that you are in charge of. Stephan, any comment on these four basic pillars?
No, not at the moment.
Okay.
Enjoying the presentation.
Okay, then let me just go on. So emission calculation. Probably every one of you has already heard of different standards. There is a HBEFA, there is a CEN, there is, Stephan has already mentioned, EN16258 and so on. There are different standards. So what is the meaning of these standards? Each one of these standards deals with, well, providing emission results based on specific input parameters and providing individual output values. They do not return all the same KPIs. The KPIs depend on the standard that you are used. For example, there is the so-called HBEFA, which is Handbook of Emission Factors. I think that's one of the, well, oldest standards for emission calculation. I think, but about 10, 12 years ago, it has been invented in the version HBEFA 2.0. And the values that you get from the HBEFA standard is more than 15 different chemical substances like carbon dioxide, nitro. Let's just look into the browser for the first time, and then we can, not this browser, that one. So here we go. Here we go. These are the values that you can get from the HBEFA, from the Handbook of Emission Factor Standards. You can see a lot of chemical substances. Back to the slides. On the other hand, we've got the well-known standard that is called ZEN, and the ZEN just returns some core values that are, let's say, energy consumption, so kilojoule, megajoules per distance, and so on. And on the other side, it also mentions a carbon dioxide equivalent. I will explain the meaning of carbon dioxide equivalent in a few slides. So there are some important parameters that have an influence in the emission calculation, and the parameters that are required on the input side, they depend on the mechanism, the method you have chosen for the emission calculation. For example, in the CEN standard, you could provide information about the fuel consumption and the type of fuel that you have, while in the HBEFA standard, you provide physical attributes of your vehicle, like the, well, standard weight, total weight, the load weight, the size of the engine, and so on. And based on these values, the algorithm is enabled to calculate its output, like the 15 substances or the energy consumption. That's important to understand. These algorithms, they can be quite different in what they need from you as input and also in what they provide as output. But altogether, they provide emission information. So, okay, let's look at the emission calculation. Where do we need it? You could be interested in calculating the emission of a transport on the scope of a total route. So if I drive from my central depot to 20 different customers and back to my depot again, you could be interested in what is the emission that is produced on the whole round trip. You could be interested in the emission per single leg, so from the depot to the first customer, from the first customer to the second customer, and so on, or in our terms, from waypoint to waypoint. For some reason, you could be interested in a more detailed level, like what is the emission per single road segment. And one thing that I've highlighted here in red color is it is also helpful to calculate the emission if you want to report it on the base of an individual transport order or an element of your transport order. But that's not part of today's session. That's something where you would have to discuss how you can derive order-based emission from the total route, the leg-based or the segment-based emission calculation. What is also important is for the emission calculation that you could compute the emission based on different means of transport. PTV's core competence, of course, is the well-known road-based calculation. We are the experts in routing, but we also can offer interfaces where you can deal with rail or air or sea-based transport. For that, we have an intermodal service, Intermodal. And if you're interested in these three parts, not road-based calculation, come back to me later. I can discuss with you about our PTV Intermodal. And we will have a webinar about intermodal in 1 or 2 weeks, 1 week. Yeah, so each one of those modes has an appropriate algorithm how to compute the emission. And PTV is dealing with the road-based transport. So what is important at that level is that you understand what is the wording at that level. For example, one important thing is that CO2, well-known abbreviation is carbon dioxide, of course, that's a chemical substance. There is also a term that is called CO2 equivalent. And sometimes what I encounter in discussions with our players is that they mix up these two terms, the CO2 and the CO2 equivalent. These are not the same. CO2 is the chemical substance, and CO2 equivalent means that any other substance, remember those substances that are mentioned in the HBEFA, for example, each one of those substances is said to cause a specific damage to the environment. And there is a correction factor between CO2 and one of those other substances that says how much of those substance do you need to have the same harm to the environment as 1 gram of carbon dioxide, for example. And that's the CO2 equivalent. Okay, what we do with the CO2 equivalent calculation in an emission report is that we just determine the harm of each substance, the CO2 equivalent of each substance, and then we sum up these values to the total CO2 equivalent value of a route or a tour, for example. Okay, it's quite silent in the audience. Any questions so far? Any feedback? Any sign of life? Stephan, anything to add from your side?
Nothing to add from my side. So it's just important that that all of you calculate CO2e if you make your CO2 calculation, because this is exactly the value which will be compared between the transport modes. And even if you compare different modes like air traffic or train traffic, etc., it's important to have this value and not only to calculate CO2.
Okay, thanks.
And you're in line with the standard, of course, and the European and the prepared ISO standard. So it's the calculation method you should use.
Okay. Here's just a list of some more of the substances like carbon monoxide, carbon hydrogen, sulfur dioxide, and so on. They are all relevant in the term in the context of emission calculation. So now from a more closer level, as I said, there are different approaches towards emission calculation. There is a link already here in the on the slide. Let's just have a look at that link as well. It's that one. Here is a central article I have posted some months ago, and here you can read about some core information that, for example, we have 2 major categories of algorithms. Some algorithms are in the Schublade factor-based, while others are in the category comprehensive. So each one of those standards has been defined in the context of a, let's say, specific geographic region. So we've got some European HBEFA is quite common in Europe. We've got the Coopert standard, which is popular in Australia. And on the factor-based side, we've got some also some European approaches in the SEN standard, which is also known as the 16258. And we've got the colleagues from the UK, and our French buddies also have their own CO2 emission standard. The pages are public, so if you want to look into those details, and just feel free to do it. I have also linked them to the documentation and give you some more information about what you have to consider in the context of emissions. So coming back to these overviews, the two approaches have already been mentioned, factor-based and comprehensive. Factor-based means it's a very simple structure of you provide some input values like the amount of gasoline that you have consumed on a trip, and this value is just multiplied with a static look-aside tables, and then you get the emission output. And on the other hand, we've got the comprehensive approaches like HBEFA. Here we've got some very, very detailed amount of data tables that contain different vehicle properties like engine size, total weight of vehicles, and many more properties. And then we have to multiply your input values with these very, very detailed standard values from the look-aside tables. What is also important to mention, for example, if you drive from a valley to the top of a hill, of course, you produce a totally different amount of emission compared to if you drive from the hill down to the valley. And depending on the standard you apply, the standard is able to handle these elevations or not. For example, in the early versions of the Handbook of Emission Factors, they did not consider the elevation. And since HBEFA 3.1, the elevation is part of the way how to determine the emission calculation. And of course, the latest version of HBEFA is, correct me if I'm wrong, I think it's 4.1, and it's already part of our API.
No, it's 4.2 since yesterday.
Really?
Yep, they updated. But
okay.
It's only minor changes, but the newest version is 4.2.
Okay, good. So as you see, also these standards are still evolving over time. Okay, now let's start. Let's have a closer look at the SEN standard. Stephan, we had some discussions about this. From your perspective, the SEN standard is the most important one in Europe nowadays, or the future one?
Yeah, of course. So of course it's the only standard we have in Europe. Of course, the French calculation method is not a standard; it's more a law to which you have to fulfill with the factors. But the 16258 is the only standard we have at the moment, and the next standard will be ISO 14083. This will be published in October this year, I guess. But the general base for road transportation is almost the same. Only the distribution centers and the emission for the distribution centers, they will be added.
Okay, so now it's what is part of the SEN standard? SEN is one of those factor-based standards, and for those standards, you have a very simple input, a very simple approach of parameters for the input. For example, you specify that you are driving with diesel, with gasoline, and you have a specific amount of fuel that you consume on a specific trip. There are different, let's say, use cases or use case scenarios or stories. Let's have a look at them one by one. The easiest one, of course, is you simply know how much fuel you consume on the actual route. So if you drive from Karlsruhe to Frankfurt, you start with a full tank, and once you are at your destination, you fill up the car, then you exactly know how much fuel did I consume during that ride. That's the best level because it's absolutely precise in terms of the current route that you drive. So that's one of those stories. And if you have information about this level, then you should really apply it. As I said, it's the best value you can provide. The second level is the vehicle specific. Let's say you know you're driving over the year 200,000 kilometers, well, quite a lot. Let's say 100,000 kilometers with your truck, and you know the average consumption of this specific vehicle. So if you know it in average, you consume 40 liters, you can just apply this value to your current route. You know you're driving 140 kilometers, then you can just have a linear factor which refers to your specific vehicle's history. The next level is the fleet specific. Now, quite often you know that all the trucks in your yard have a total consumption of a specific amount of gasoline, and also they drive in a specific amount of kilometers during the year. So you've got a fleet specific average, and you can apply or multiply this fleet specific average with the current route length. Of course, it depends on the on whether your yard is homogeneous or heterogeneous, whether this is a precise value or not. The fourth level is the route specific. That means if you are driving a specific track several times during the day, during the month or the year, and you just know what is the average consumption of your trucks that are driving this route recurring, then you can just derive the route specific consumption. These are the four standard stories, from the top, which is the highest quality, to the bottom, which is the, let's say, lowest quality. If you can apply a higher level, you're recommended to do this. And there's also a fifth approach, but that's now a bit different because the fifth approach is HBEFA based. That means the Zen standard uses another standard, the HBEFA standard, to determine the consumption of the fuel, and then just uses the HBEFA output as an internal input for the algorithm. Anything to add, Stephan?
No, but don't use the emissions from HBEFAs, but only use the fuel consumption from HBEFA, because this is, then you're completely in line with the standard. And most of your clients or your fleet operators should have fleet specific values or vehicle specific values. So from my experience, most companies use the fleet specific values, which means you have an average value for your light duty vehicles, an average value for your 40-ton and 12-ton trucks, and that's it. And this is a very exact measurement you can do with the kilometers traveled in 1 year and the fuel consumption you have in your fuel card. So it's easy to get this data, and it's the really accurate value. And of course, you always can use the consumption values from the handbook of emission factors, but if you have the own values for your own fleets, then you should use this.
Now let's have a look at the output from the Zen standard. So the core output of each one of those 4 or 5 stories is a value for the fuel consumption on a route. And we also return the energy consumption in the 2 different versions of tank to wheel and well to wheel. So there is, maybe you've already heard these terms, tank to wheel, well to tank, and so on. Let me just introduce you in their meaning. So well to tank means that's the energy consumption before the transport. So what is part of that section or part of the process is contributions that are like battery charging, fuel production, for example. That's from the production to the vehicle. That's what we call well to tank. So the next level is from the tank to the wheel. And this is the contribution that is created in the vehicle during the transport. So this is also related to the efficiency factor of a vehicle, for example. So well to tank, tank to wheel, both parts together is well to wheel. So that's the complete, well to wheel means the complete chain from the production to the consumption on the road. I hope that's clear in these simple words.
Yeah, just one thing to add. So if you calculate these values and if you apply the standard, you have to report these values. That means you have to report the well to tank and the tank to wheel emissions. Then if you use biofuels or you use, for example, the electric vehicle for the power consumption for electric vehicles, then the tank to wheel emissions are 0 because you do not have any emissions in this part of the chain. But you have emissions, of course, in the fuel consumption to produce the biofuels, and that's the reason why you have to calculate both. And you also have to report both parts of the chain.
What's also important is that electric mobiles, they have a very positive or very good efficiency factor. But the challenge in the e-mobility sector is, of course, how to gather the power in the pre-production. So if you consume, let's say, energy from sources that are producing a lot of emissions, well, then it's not good in terms of reporting the e-mobility stuff. Okay, so this is about tank to wheel, well to wheel. We've got the CO2 equivalent in kilogram, so that I also have to mention the units of these values. And we also compute the CO2 equivalent from tank to wheel and from well to wheel. Any questions from the audience so far?
I think it's worth to mention also the megajoule value, so that if you apply the standard, you need to calculate not only the CO2e but also the pure energy in megajoule. This is because if you want to share this data with other companies and they apply other factors for CO2e based on the fuel consumption, then they can use the megajoule values to make their own calculations. And the standard says we want to be as compatible as possible with all the other calculation methods, and that's the reason why we also with PTV X server and PTV developer calculate the megajoule values for all transport legs.
Okay, let me just have a look at this output. This is a sample client where I can specify, for example, I'm driving from Karlsruhe to Frankfurt, and this client returns the Zen-based values for the stories that I've already told. So the actual, the fleet-specific, route-specific, vehicle-specific, and so on. And for each one of these 5 stories, we get the CO2 equivalent from tank to wheel, from well to wheel, and also the energy just mentioned by Stephan in megajoules. And we also get the final value for the fuel consumption. Now let's have just a quick glance at the values that we see right now. And here are, of course, some input values. Remember the stories, here is the fuel consumption. This parameter means this truck has an average fuel consumption over the year of, let's say, 40 liters per 100 kilometers. And in this example with diesel, of course. So that means we will find the consequence of the 40 liters here in the vehicle-specific average fuel consumption. So if I change this value to, let's say, the double value, 80, then the last line in the example should also grow by the factor of 2. Maybe you've seen the fuel consumption has just doubled. Of course, that's maybe a bit ridiculous high, but I just wanted to display the consequences that this value has now changed. About the other values, we've got the fleet-specific average consumption, 35 liters, that will have an impact in this line. We've got the route-specific average consumption, that's of course having an impact on this line, and we've got the actual fuel consumption for this route. Now let's have a quick look at the actual fuel consumption. We've got a route of about 140 kilometers. We consume 45 liters, and this value is the amount of fuel that is consumed for the whole 140 kilometers. So we do not have to multiply it with 1.38, for example. We simply know this is the amount that is consumed. Now, the physical density of a single liter of diesel, for example, is 0.832 kilograms per liter. And that means if we consume 45 liters, then we can just look into this line. So the question is, why don't we have 45 kilograms? Of course, because of the physical density. If we use a calculator, here we go, 45 liters multiplied with that value is the output that we get here in the fuel consumption. You can see that's a quite simple approach. If you know these correction factors or these multiplication factors for the specific fuel type, for example, you can simply implement the SEN standard using this. But of course, we can also return these values with our APIs. Any questions about those 4 stories from the audience? or anything else you would like to see here in the output. In the meantime, maybe you can just change to another profile, let's say 40-ton truck, and just remove these values. By the way, I don't think we have standards for them. Does make sense. There is no default value. Let me just go back to 30 liters and route specific values. And of course, if these values have an equal level, then the output will also return same values. If we look into, I will keep it short, if you look into the requests that are exchanged with the server, we can just see that you can specify that you want to have these different stories to be applied, and you can also find the values for the consumption, the 30 liters here, the 45 liters, and so on. The response will then take some time because it's quite a long document. And then you see that we've got, maybe let me just remove per segment for a second. Should not take that much time. Here we go. We've got the polygon line at the beginning, and at the end we see the values for the different standards, for the different stories with those values that you've also seen here in the tables, of course. So it's not a complicated parameter set. It's a simple set of elements that you can gather from the response. Okay, now let's move on with the next slide. There is one topic that we've already been asked quite often in the past, and that's the term GLEC. GLEC is an association which is called the Global Logistics Emission Council. And sometimes partners ask us for, hey, is PTV part of the GLEC? Does PTV support GLEC? And is PTV GLEC certified? And these kind of things. So the question at the beginning is, what is GLEC? GLEC is an association that is built by different parties from different industries, as you can see here. So we have hauliers, we've got industries that are producing stuff, we've got hard and software providers, and we've got different environment associations. They all are part of the GLEC, and GLEC is not an official law. GLEC is, let's say, an economy association, kind of. And what GLEC does is they define, let's say, an approach of how to compute emissions, but this is not an official law. It's just some kind of de facto standard that becomes more and more relevant. And for example, GLEC is also dealing not only with the road-based emission calculation, but also with the other means of transport. And PTV is contributing to this. So when you want to when you want to compute emissions based on what GLEC says, you can use PTV's component to cover the means of transport on the road. So, right, Stephan, anything to mention here?
Yes, just want to add that GLEC is really like Bernd just explained, covers all the transport modes and covers also, and that's the critic of the European standard, the logistics sites and the, I don't know the English word, Umschlag. Someone can help me. So the work in the distribution center, of course. And this will be added in the ISO standard, of course, in half a year. And if you use the EN16258, you are 100% in line with the GLEC requirements for the mode, for the transport mode road. So this is exactly what we do. And I don't know if you have this chart available, Bernd. There you can see how the emissions are calculated in the GLEC framework, and for road transportation there are exactly two methods. One is the method for the European standard, and the other one is from the US calculation by EPA. I think it's in some kind of PDFs you can see the overview, but
not sure where I used to have it, but I'm not sure where I have it right now. And that was not part here. Maybe we have to provide it afterwards. So yeah. GLEC covers the different means of transport, and imagine, well, there's at least one article in the forum about the GLAC as well. Let's look for this.
I will post it in the chat. So if you have a look to the chat, you can see it, and there you see all the calculation methods which are proposed by the GLAC.
Okay, maybe you refer to what is also described in this article. So GLAC is dealing with the different means of transport. For air transport, they use the IATA recommendation. For inland water, they use SmartWay Barge Carrier Tool or the greenhouse gas emission factors. For rail, they use Ecotransit. Maybe you can all introduce us a little bit into what is Ecotransit, Stephan? Some words about that.
Ecotransit is a non-profit organization, or the organization behind is EVA in Hanover, I guess, and they are the only provider of consumption for rail. So they are the European-wide standard to get the most perfect data for power consumption on railroads. This is what Ecotrans IT does, and of course they calculate also the other methods for ship and barge and air, etc. But the main purpose is, of course, the rail.
Okay, thanks. So then, of course, we've got the road-based approach, which is GLAC uses the Zen standard 16258 for the road-based approach, and that means we can contribute in the GLAC approach because PTV offers, besides other standards, we also offer 16258, which is the Zen standard. So if you want to be GLAC conform, you can use PTV's component for the road part of the emission calculation.
Exactly.
As you've already seen. Well, okay, let me go back to the slides. So any questions about GLAC? I know that some of you who are in the session have already asked me about GLAC, and so I hope that this summary is giving you the answers that you have been looking for. If not, come back to me later or ask right now. Feel free. Stephan can maybe give you some more details then. Okay, so now from a technical perspective, remember at the beginning I said you can compute the emissions for a total route, per leg, per segment. So we have different PTV interfaces, and typically I'm dealing with the developer APIs with our APIs. So we can calculate emission calculation in X-Route 1, in X-Route 2, and also in the latest, in the state-of-the-art PTV developer, which is the API that we've released about half a year ago, I think, in the cloud. So the parameters you have to mention here for this is the profile properties, the engine size, the physical attributes of your vehicle. So some of these properties you are already quite familiar with because you also need to specify them for the truck attributes. If you want to consider where are you allowed to drive by using the PTV truck attributes, for example, then you know that total weight has an impact on the geometry of a route, but with HBEFA it also has an impact on the emission output values of these parameters, of these algorithms. You've seen in the Zen standard that you can provide the fuel consumption and type. We've seen this in the sample request. And of course, you have to specify for the Zen standard, you have to specify whether you want to compute the actual route or one of the other stories that are available. So here is an overview of which standard is covered by which one of our APIs. So in X-Route 1, we can calculate the COPERT, the Australian COPERT. We can calculate the Zen standard and also HBEFA 3.2, but we did not implement HBEFA 4 anymore in the old X-Route 1 interface. In X-Route 2, we can cover HBEFA 4, and current version is 2.25. I think in a few weeks we will also release 2.26 with some more enhancements. And in PTV Developer, we can also calculate HBEFA for Stephan. Which ones of these modes do we cover? Let's just have a look into the emission calculation.
So yeah, it's important to understand that the pure handbook of emission calculation is really not used in the use cases we have. We use from the handbook of emission factors all the consumption values, of course. This is the default value which is allowed from the European standard, and there we use really millions of data sets from handbook of emission factor. But the pure calculation is not a good approach for the issue we have. So it's more used for traffic modeling and to calculate not only emissions but emissions also on the road. If you want to know, for example, how many vehicles from which year and category and consumption, etc., are traveling on a specific kind of road. And it's more from the modeling side where you need this information, but not in transport and logistics. So that's why it's not in PTV developer, but it's not needed there because we have all the values related to the European standard.
Okay, here is a quick glance at the API. I said today is not a technical training, but let's just have a look at the PTV developer approach. Here you can see the method signature of the standard routing approach. So give me 2 or more waypoints. We will calculate the polygon, the distance, the driving time, and you can also request additional optional response elements. And here among them, you can see there is the SEN standard for the HBEFA, there is the regular SEN standard, there is the French version, and so on. If you want to have any one of those standards in the response, just ask for them in the array of potential results, and then you will get them. So it should be quite simple. So some other questions we had in the recent sessions was when will PTV provide the CO2 emission equivalent optimized route or tour? Stephan, any feedback from your side about this, as you are in charge of strategic statements? You're muted.
Sorry, the CO2 optimized route or tour. So this is really difficult. So we need another session for this with a minimum of 2 hours because it's really complicated. At the end, what are you doing if you optimize a trip or not a trip, a tour by CO2e means you try to optimize it by energy consumption. And this is, of course, exactly what we do with our components. We try to use only the needed resources depending on the optimization goals you have, and you tell us in the API request. So this could be minimizing of time, minimizing of stop-off points, minimizing of used vehicles, etc. And of course, the fuel consumption is always a measurement which you want to reduce. But to have this as the first rule of optimization doesn't make any sense from a logistics kind of view, to be honest. Okay. So it's something we should discuss after the next local PTV event at headquarters or on a trade show.
Okay. So next question.
Can I have a question? Hi. Can I have a question?
Yes, sure.
So what's the actual problem with optimizing by the CO2 emissions? Isn't it very similar to optimizing just the route and fuel consumption? How would the route look like if you just optimize it with the CO2 consumption? It would be very much longer, or how would it look like?
We don't do this at the moment, and the question is always, should we do this? But the normal routing is, of course, optimized by time and kilometers. So this is if you have a route from A to B, the stuff you want to optimize is time and kilometer. And if you now want to optimize also the CO2, so the fuel consumption, you have 3 values you have to optimize, and that's I'm not sure if this makes sense, to be honest.
Okay, let me give you a feedback about what is the optimal route and what is the optimal tour. Optimal always means that we want to find a minimum or a maximum for a specific KPI. So now in terms of routing, what we use in the routing context is we've got conventional routing where we have costs for each road segment, and these costs are virtual costs. It's not a real price in euros, it's an abstract value. That was the old school routing engine, and about 1.5 years ago we invented a new algorithm or a new approach towards cost optimized routing. And with this new approach, let me just show you a little example here. Let me calculate a standard route using a routing engine. Now, what we do with cost optimized routing, let me keep it short, is we can consider several factors which have an influence on the price of a route. These factors are the costs per kilometer of the vehicle, the costs per hour of your driver, and we can also specify, for example, the costs per energy unit, for example, 1.60 euros per liter of gasoline. And you specify somewhere else in the API, you specify your 45 liters average consumption per 100 kilometer, for example. And a factor that is not mentioned here is the toll. So the price you have to pay if you are using in Germany a highway or a federal road, for example. So the 4 factors are the cost per kilometer, cost per hour, cost per energy, and the toll. Toll is not a parameter you can influence. Toll is something that is given by the authorities, of course. So now the cost optimized routing is returning that geometry that minimizes the sum of these 4 factors. And that's what we do in the context of monetary cost optimization. Now, once we know the geometry, and that's important to understand why we do not provide the emission optimized route so far, is once we know the geometry, we post-process the route to determine the emission output. So at the time when we determine the best path through the network, we do not deal with emissions. We do it afterwards. And it would be the same in the tour optimization, where you want to minimize the contributions of driving distance, driving kilometers as well. But over there, it's not possible at the moment. Maybe at a later stage, as Stephan said, we could talk hours about that specific topic, why this is not possible at the moment. But if you are talking about regular routing, we can already consider the cost optimization. And just for your information, if we look into the vehicle's engine, we are also able to deal with how much fuel compared to your average consumption do you consume at specific velocities. So that's already a very flexible approach, and of course you can use it to find a route that reduces the emission output if you have proper values for the fuel consumption. Okay. So much about that. Okay, a little excerpt. Okay, which standards will be available in what interfaces? So now we've seen the table a few seconds ago where I mentioned what is possible in X-Route 1. X-Route 1 is feature frozen. We will not implement new standards or updated versions of standards in X-Route 1. Stephan, your perspective towards X-Route 2? You're muted.
Sorry, once again, sorry. There was a distraction here, sorry.
So do you want to comment on how X-Server 2 is dealing with future standards or updates of existing standards?
There are no changes. They will be updated, of course. So it's a product we sell at PTV, as in also to new clients. So everything fine. Okay. Or what was there a more complicated question behind?
No, I'm okay with that. Well, as long as the audience doesn't have any other questions dealing with that. Let's just...
No, all the data and of course the calculation methods will be updated in X-Server 2 as well, of course. Yeah.
Okay. So for those of you who have not been dealing with PTV Developer that much so far, PTV Developer is the new API, and some of the components behind PTV Developer are still the well-known X-Server 2. For example, in Xtour, whenever you do an optimization in Developer, tour optimization in PTV Developer, you will in fact use X-Server 2, Xtour 2 in the backend, just with a different API, with a more simple API. for example. Okay, e-mobility. How does PTV deal with e-mobility? Does it make sense to ask for emission output in e-mobility? So even our colleagues in France, if you would like to comment on this, just let us know. What about other substances like LNG, CNG in that context? Do we already cover this? Do we have to do our homework to be up to date with those values, or is it how to deal with that?
Hello, everybody. This is Sébastien Béolet from the French team implementing the emission algorithms for server and the PTV developer. So yeah, for the e-mobility, our plan is to integrate the new alternative drivetrains into the future version of the engines. It is not covered right now, but we really plan to work on this in the next months, so to have it available very soon.
Okay, great. Next question, what are the differences between historical route, or can we deal with historical route calculation and future route calculation? So what is meant by this statement is, of course, when you use a routing engine such as PTV Xroute2 or PTV Developer, you're providing 2 or more coordinates and you want to know what is the best way from A to B, from B to C, and so on. And that is a route we recommend for you to drive as the optimal route. As I said, being influenced by various parameters such as the costs and physical dimensions. So there is also the need for creating a report of historical routes. That means a route you have been driven in the past, and quite often you have a set of GPS coordinates recorded during the day of a truck, for example, and then you would like to reconstruct such a route. That's possible. You can do this. For that, we've got the so-called matching use case, which is also available both in Xserver 1 and Xserver 2 on-premise, and also in PTV Developer. So if you want to reconstruct the route, you can just use the matching API. Let's have a look at this. Here we go. Here's the map matching API. And here you can provide your detailed GPS coordinates that you have tracked, let's say every minute, for example, and then we can use the output of the map matching API to reconstruct a route with the routing API. So here we go. Use the map matching API to create a so-called path, and then the path is the output of the map matching API, and then use the path as an input for the routing API to determine what is the emission value according to a specific standard on the reconstructed historical route. So that's also possible. And we've got some forum entries about this as well. Then we've got which one of the sense scenarios covers height profiles. Let's just have a look at those standards again. Here we are. So kind of actual fuel consumption. If you know that you have consumed 45 liters on a specific road today, on a current route that you have been driving today, then this is, of course, reflecting whether there was some elevation on your route or not. So you just take your time to think through each one of these scenarios to find out whether it covers the elevations or not. I would say actual fuel covers it. The others, each one of these standards that is based on an average is not reflecting the height. But it depends on whether your fleet is always driving on uphill, downhill or not. But you cannot give a generic, shouldn't give a generic statement on this. Intermodal routing, as I said, we will have a webinar about intermodal routing on February the 9th. If you want to participate in that webinar and you have not registered so far, just get back to me and then you will get the registration link. That webinar will introduce you into how PTV's routing engine or a specific version of the routing engine is able to deal with specific custom timetables. So in a regular routing engine, when you use a ferry from Dover to Calais, for example, then we just know there is a connection from one from one coordinate to another coordinate, and it takes 2 hours to get from one coordinate to the other coordinate, but we do not know the exact timetable of the ferry. With X Intermodal, you can upload your information such as timetables, such as prices into the X Intermodal, and then this will be considered in the routing process, which then returns various alternatives, and you can choose off the different routes. But that's a very special component. If you're interested in this, get back to us and join us next week. So,
sorry, is this intermodal routing available right now, or is it just is production ready, or this is just something that will be available in the future?
That is already available, and if you want to have a test version, I will create a link between you and my colleague Florian, who is the moderator of the intermodal webinar next week, and we can, well, at a first step, we can provide the documentation to you, so you can look into what is the API, what methods are available, and also what tools are available around it, because that's quite special in the intermodal service. You have to upload data. You have to provide the timetables. It's not PTV who gives you the timetables.
Yeah, but we have some like on premise, then we can just have it on the data uploaded to our servers, and then like can it be seamlessly integrated with the X-Route, or this is just some different service?
It's a different service. It's a different API. So obviously you're interested into it, register for that session, get back to me after the webinar, and I will put you on the list for participants.
Yeah,
and
sure.
What Florian will also show is the tool set around it, because there is also a data manager where you can upload your timetable files, for example, and so on. So it's not only a programming interface, there is also some tools around it. Yeah. So the next question is interfaces to ERPs and TMS. That's something you have to decide. You are integrators, you are those who are using our APIs to enable ERPs or TMS to deal with emission calculation. So feel free to use it, but that's your task. That's your level where you are active. So, and final question was so far was, what is the price model behind that? If you want to deal with emission calculation in the context of X-Server 2 or X-Server 1, you would have to license the so-called logistics package. And once again, question to Stephan, is this emission calculation? We've seen it's just it's one more optional result element in the PTV developer API. Is there a specific price model behind it if you want to use it in the PTV developer?
No, it's completely included.
Okay. Any other content which is completely included, which was not included in the old pricing models?
All content. So much more easier. So so we added the whole additional logistics and traffic and whatever content to the prices. Yeah. Okay.
So in the past, you had to pay extra licenses if you wanted to consider truck attributes, restriction zones, speed patterns, and these kind of things. But now with the developer API, it is a simplified model of licensing and integration. So a single route has the same price whether you ask for emissions or not.
And it's not a price increase. So we didn't took the higher price, we took the lower price. So it should work for you, of course. Yeah, sorry, but this was not sales, was product management decision.
Okay, well, I think nobody is against that. Okay, besides internals. Okay, so much for the questions I've gathered in the past. Any questions from the audience again? By the way, if you want to participate in the intermodal webinar, just leave a comment in the chat so I can return to you, or I can also send the registration link to each one of you. Okay, last chance for your questions. I start to shut down the session. Here is just a collection of different links, like what is emission calculation in general, what are the different sense scenarios, what is the connection between PTV and GLEC. Oh, by the way, are we certified? Yes, no, not yet. About to come. Will we buy GLEC? Will GLEC buy us? Whatever. Any feedback about this, Stephan?
We're working on it. It's difficult because from a product perspective, we do not need the certification, of course, because we are 100% in line with the calculation of the European standard, and this is exactly what GLEC applies also. So it's nothing to deal with. But from a marketing point of view and of course the events from GLAC and all the other stuff around, it makes sense to be part of the GLAC, and this is what we discuss internally at the moment. And then we will have also the accreditation, but it's more it's nothing with a new development. It's just something we have to do and to decide internally.
Okay, thanks for that info. Here's some information about intermodal services. We've got the links to the showcases and to some Wikipedia articles about what is the difference between well-to-wheel, well-to-tank, and tank-to-wheel. Well, that's it from my side. If you do not have any further questions, we are done for the moment. Thanks for joining. Thanks for any kind of questions. And well, we will keep you up to date with future webinars about restriction zones, performance optimization. If you have some topics you would like to request for future webinars, just get back to me. I'm always open to discuss about technical aspects, functional aspects. As you know, I'm a ramp pig, so thank you very much for joining today, and see you again in the next round. And
thank
also,
you. Thank you, Ben.
Stephan, Sebastian, and all the other colleagues. Thank you for contributing.
Bye-bye.
See you.
Thank you. Bye-bye.
Thanks a lot. See you. Bye.
Goodbye.